Hello, my name is Andrea Sanchez, and today I'll be talking about lattice addition. But before I get into that, I'm going to start talking about standard algorithm, which is the addition that we are used to today. So here we have an example of 23 plus 29, and we know that 9 plus 3 is 12. So when doing standard algorithm, we know that we put the 2 here, and we are taught that we carry the 1 over here. And this is because we have 12 units. And with 12 units, we're able to make one long, which is the equivalent to 10 units, and we'll have 2 units left over, which is just 2 of these, which is why we put the 2 here and carry the 1 on top of the tens place. Moving on to the tens place here, we have 2 plus 2, which is just 4, but since we added on the extra long, we will have the 4 here, plus the 1 long, which is just going to be 5. So the answer here will be 52. Moving on to lattice addition, we have the 2 boxes here. And this is because with lattice addition, we add using a box that will each represent a place value. So here we have this box representing the ones place, this box representing the tens place, this one the hundreds, and this one the thousands. So as you can see here, we have the ones, tens, hundreds, thousands. And with lattice, we split that box in half in the same sense, this one representing the ones place and this one representing the tens place, as you can see here. So this is just a zoomed up version of that. So moving on, we have 23 plus 29. So here, we can see that 9 plus 3 is 12. The beauty of lattice addition is we don't have to carry over, so we just put the 1 long here and then the 2 units here. And then we have 2 plus 2, which is just 4. So we have the 0 here and the 4 here. So with lattice, we add diagonally. So here we have 2 plus nothing, which is just 2, and then 4 plus 1, which is just 5, and then we have here 0. And this is because we have the boxes representing each place value. So here we have the ones place. And then when adding diagonally here, we have the tens place. You can see here. And then lastly here, we have the hundreds, which we're not working with at the moment, but we will. So here we get the resulting answer of just 52, which we can see here. Now moving on to an even bigger digit number, we have 8,649 plus 5,904. And here we know that 9 plus 4 is 13. And using the same logic as this one, we just carry the 1 over just like we were taught. And then 4 plus 1 being 5. And then 6 plus 9 being 15. And then 8 plus 5 being 13 plus the 1 that was carried over, so 14. So here we have 14,553. And now moving on to lattice addition. Here we will be using all 4 boxes. Here representing the ones, tens, hundreds, thousands. So we will draw out the boxes. Here having the ones place, the tens place, the hundreds, and thousands. Similarly, doing the lines diagonally, having the ones, tens. So here we have the 9 plus 4 is 13. Then we have 4 plus 0, which is just 4. And then 6 plus 9 being 15. And then 8 plus 5 being 15. And then using the same logic as before, we here have the adding of addition of lattice, and we do it diagonally. So here we have 3, because it's added to nothing. And then we have the 4 plus 1, which is just 5. And then we have the 5 plus 0, and 3 plus 1. And then the 1. And once again, we can see that here, with lattice, we're able to show that to the child that they can automatically see that here we have the ones place. Here we have the tens place. Here we have the hundreds. here we have the thousands. And lastly here we add the biggest digit here, which is 10,000. The child will then be able to quickly see that without confusion of carrying over and accidentally forgetting to add one number, they can just use the boxes to help them see it visually. So here we get the answer of the same over there, 14,553. With this, we can implement into the classroom to be able to allow the child to see how differently what each place value represents, how easily they can add it diagonally, and how it will be more for a visual learner, and they can have discussions upon themselves and just discuss how each place value here is added and how they could just automatically see it going diagonally down versus maybe getting confused of carrying place values over and forgetting to add something. So this is just another way of doing addition, and it can be implemented into an everyday classroom. It doesn't have to, but it's just an easier way for a child to see how to do math.